All right. Jumbo once more. We have already dealt with what is a small circle and what is a great circle. Now, this part is, we will look at the relationship between the radius capital R of a great circle and the radius small r of a small circle on the same sphere. It has to be on the same sphere. So we are considering these two horizontal circles. The one with center O is a great circle because we have said it has the radius of the sphere. The one with center P, I want to make them clear. So this is center O and this is center P. Is a small circle with radius R. We want to look at what is the relationship between R small and R capital. Consider this angle theta. This angle theta lies on a transversal which has the length of R. Remember, R, or radius of a sphere, is the distance from the center of the sphere to the surface. So OB is a radius, OC is a radius, and any other distance from the center to the surface, it becomes a what? A radius of the sphere. So now I want us to extract. We extract triangle so this is part B, this is C, this is P, and this is O. So, because this is a distance from the center of a sphere to the surface, so it is a radius of the sphere. And this one is the radius of a small circle. Now, if this angle is theta, and we have said that those horizontal circles are parallel, that means even their diameters are parallel. This is the diameter of the great circle, and this, the radius, and this is the radius of a small circle. So now we have created a transversal OC. That therefore means if this is theta measured from here to here, then even this one is theta because transversal angles are equal. If that be the case, then we can say from trigonometry, cos theta, this one, is equals to adjacent over hypotenuse. In our case, the adjacent is R, and the hypotenuse is capital R. So we can say R small over R capital is equals to cos theta. So what is R? If I multiply both sides by R, I get that R small is equals to R capital cos theta. So this is the relationship between the radius of a small circle and the radius of a great circle, or the radius of the sphere. And this is what we have shown there. So this angle BOC is equal to angle PCO because they are alternate angles lying over a transversal. And therefore, using trigonometry, we find R is equals to R capital cos theta. Now, this is a formula that will help us get the radius of a small circle on a sphere. Okay, you have seen that. Then we move on to an example. Given that AOB equals to 30, AOC equals to 72 on a sphere of center, I'm disturbing the board a bit, center O and radius 700 meters, find PB. PB, this is P, center of a small circle. This is P, yeah. PB this is B, this is O, and this is the center of the sphere. All right. So find PB. PB is the radius of a small circle, isn't it? And we have said that this angle here is the same as this angle there. This angle here and this angle here are the same. So we can extract a right angle triangle there. Right angle, this is where the right is. So we've been given this angle as AOB is 30. So even this one is 30, isn't it? And the radius is 700, this R. So what is R? So we have said R is equals to R cos theta, which we know in this case will be 700 times the cosine of 30. And you can get the answer there. In a similar way, QC. Q is the center of this lower circle. There, QC, and this is C. QC. So QC now is the radius of that lower circle. Given that AOC, so again, the radius of, let's call this one the radius of center P, and this one radius of center Q. So this will be the angle subtended there, which is alternate, is 72. No, sorry for that. So it will be R cos theta, which will be 700 times cos 72, and you can finish that one. All right. BC. Where is BC? BC, this is an arc length, is an arc, BC. But BC subtends an angle. If this one was 30 and this is 72, so the total angle subtended by BC is 30 plus 72, isn't it? So arc length BC, we said is equals to the theta it subtends, which is 30 plus 72. All of it divided by 360 times 2 times 2 over 7 times 700. So that becomes arc length BC. Arc length BC. What about CS? What about CS? CS is a pole. CS is a pole. So arc length CS, what angle does it subtend at the center? Now remember that the whole of this angle is 90. This angle AOS, angle AOS is 90. Now if this is 72, what is this angle here? So it will be 90 minus 72 over 360 times 2 times 22 over 7 times 700. So what is important here is to note, to be able to determine the angle subtended by an arc. If you want to get the arc length, you must get it right. Remember here and this one is knowledge that you have gained from all the way from primary school, how to get that angle here. So if this is 90, 72, then this one would be 90 minus 72. But in this case, you'd have to add this one and this one. And there are many other examples that we're going to look at and exercises to be able to understand arc length as we continue. I think, again, we'll stop at that at this moment, and we'll continue with